Hello everybody. My name is Jain. I'm currently an incoming sophomore going into my second year at Cornell. And I'm planning on majoring in computer science. This summer, I had the amazing opportunity to intern at Anno. And specifically, I was under the autonomous intelligence team and I was in charge of integrating the reasoning model behind our entire project. So I'm super excited to be here today and sort of just give you guys a little preview of what I've been working on this summer. So first things first, I wanted to talk about briefly sort of what AI agents are. You may have heard of them from either previous presentations or just around, but AI agents are basically just autonomous systems that can take in information, make decisions, and then act from that information. And they're sort of able to do all of this without constant human supervision and minimal external processes or tools. Some AI agents that you might be used to, like Siri or any other voice assistants, are reactive, meaning they sort of respond in real time, while others can plan several steps ahead. We interact with a lot of these AI agents on a daily basis, like chat apps or voice systems, sort of like I was talking about before, or even self driving vehicles. So going into what drives these AI agents, there's sort of two different things. I wanted to go a little bit into the difference between traditional LLMs and agentic reasoning models. So traditional LLMs are sort of like the original ChatGPT that you may be used to, and they're primarily very reactive, right? You give them a question or some type of prompt, and they give you an answer. These models are really good at sort of this like classification style of thinking, where given a prompt, they can suggest what you should do, right? So, for example, let's say I was headed on a business trip. I might say to ChatGPT or any traditional LLM, "Hey, I need to plan a business trip," right? And a traditional LLM might be able to give me a great list of steps, right? First, they might say to schedule my meetings, then to book my flights, then find some nice hotels and find some good restaurants. But it won't really be able to do much more than that. But now, sort of going into these agentic reasoning models, these agents are much more proactive and clear. They don't just like suggest actions from a black box, they actually break down the task that they're given. They decide how to approach it, and then they go execute those steps strategically themselves. So instead of saying, here's what you should do, the model just takes care of it itself. And the way I like to think about it is that traditional LLMs are sort of like classifiers, right? They look at a task and they route it to a predefined agent or tool. They decide who should handle the next step, but they don't actually do the work themselves. But these smart orchestration reasoning models are like very smart and they're smart orchestrators, right? So they can handle the whole entire production of a task or process. These models don't just route to the next task or to the next tool. They plan the full task from end to end, decide what steps to take, and actually execute those steps autonomously. So let's talk a little bit more about why reasoning really matters. So, most AI systems today, even the strongest LLMs, are fantastic at what we call pattern matching. They can recognize context from either the prompt that they're given or any files that were uploaded or any other data that they have, and they can generate pretty fluent responses. But where they fall short is when they're faced with novel situations that they've never experienced before, or if they're given too much data and they sort of struggle to find the important context from the data that they're given. And what we've also realized is that when some of these models sort of make mistakes or give an incorrect response, they often struggle when trying to explain why they made the certain decisions that they made. So, having this sort of smart orchestration reasoning model allows us to understand how the AI is thinking. And because it breaks the problem down into steps and it solves it strategically, um, and adapts if something changes mid process, we can actually understand and it's able to explain their outputs, right? And they can also replan when assumptions fail. In this way, unlike traditional LLMs, we can set these smart orchestration reasoning models to solve much more higher complexity tasks and long term goals. So, going into what we've been building this summer at Anno, our solution that we've been building is called Panacea. And what this is an agentic artificial intelligence platform where the core of the platform is the smart orchestrator chatbot that can pull from prior conversations, user queries, and even uploaded files, all within this one reasoning context to solve tasks from end to end. And a key differentiator here is explainability. Like I was talking about before, unlike typical black box LLMs, our system surfaces its internal reasoning steps, so users can actually understand why it's doing what it's doing. It's also robust to very messy real world inputs. Whether the data comes in through PDFs, CSVs, chat logs, or all of the above, the model can handle ambiguity and dynamically adapt its approach. And finally, with smart orchestration, there's no need to hard code any workflows or build any decision trees for what the reasoning model should do. The model itself can just figure it out on the fly, right? It can just figure out the right flow at runtime. Even if it's given any edge cases or novel use scenarios, it's able to adapt dynamically. So this was a short demo recorded by one of the other team members on the autonomous intelligence team, and I wanted to watch it to sort of walk us through the key features of the platform. So when you first log into Panacea, you can see that you're greeted with this homepage where you can upload files, you can give a prompt to the AI, and it'll give you a response. So we can first start out by just greeting ourselves and saying hello. And you can see that the AI starts thinking once we give it a prompt, and it says, "Hello, how can I assist you today?" After that, we'll tell the AI that we want to upload a file. So we can see also that given our previous query, we can see the different reasoning steps that the AI took before giving us its response, right? We can see that first it had to process the query that we gave, right? This hello. And then since there wasn't much more data or any other information that it needed to gather, it was able to give us a response pretty quickly. And this was that completed response. So now, once we told them that we wanted to upload a file, again, it's going to give us the reasoning steps, but it's basically just telling us that we need to upload our file using the upload file button. So what we'll do just for the demo is upload a file that is basically just a summary of MTA subway entrances and exits, and it's basically just this overview of MTA subway routes. And we'll ask the AI to summarize the document that we provided. So we can see that the AI takes a second to, digest the document and think over what it should do for a response. And then we can see that here it was able to give us a very decent summary of the document that we provided. And it also shows us the reasoning steps that it took to get to that output, right? So first, it understands that the user wants a summary of the file that they just uploaded. So they look at first the chat history, right? What have we talked about previously? Is anything relevant to the task that we need to complete at hand, right? Then it looks at the document that we provided. It retrieves the document and it finally completes the request. So now, why does all of this actually matter? Well, the core challenge is that while most LLMs today are incredibly powerful, they tend to behave sort of like black boxes, especially when they're faced with complex and multi step tasks. So, sort of breaking that down, first, they're not very explainable, right? Most agents today can give you an answer, but they can't reliably tell you how they got there. That makes them pretty hard to evaluate and rely on in production grade or highly sensitive settings. Second of all, they have very limited capabilities. LLMs are great at answering isolated questions, but they sort of struggle with planning, tool usage, and dynamic workflows. They don't know how to chain actions together, especially when the context of the task at hand changes. And finally, they're hard to trust, right? If a model doesn't show you its reasoning process, it's very hard to debug, to validate, or to deploy it with confidence. Reasoning models, especially smart orchestration reasoning models, solve this by offering interpretability. You can get a visible chain of thought, which makes the AI much more auditable, safer, and more robust for real world use. Looking ahead, there's two big areas that we're focusing on to take this platform to the next level. So, first, we sort of plan to adopt more advanced reasoning models as they continue to evolve. Today, we actually just saw that GPT-5 was released. And so, as these sort of new architectures and reasoning models emerge, we plan to integrate them directly into our orchestration layer. That way, we can consistently upgrade our system's ability to handle longer chains of reasoning, more complex tasks, and have overall just better decision making. Second of all, we're working on expanding support for our external tools and services. Right now, we've built integrations for basic file types and context-aware task execution, but in the future, we want our platform to connect seamlessly with internal APIs, data lakes, and much more. The idea here is to make the agent not just smart in isolation, but actually useful in real workflows. So, regardless of your field, whether you're in finance, legal, research, or operations, the system should be able to directly plug into your environment or whatever you need to work on and just take real action. Ultimately, our goal is just to make this platform more robust, more capable, and more adaptable as the tech landscape evolves. Thank you.